Yo, hello, what's up? Why am I lagging? Looks like it's gonna be a one-to-one today. But I think maybe after 1 hour, Ryan's gonna come because he has something earlier.
Okay.
Okay. All right. So this week is gonna be week 2, and then we're gonna be doing functions. And for you, this is good because you get to practice what you're doing at school. Okay.
Mm-hmm.
Okay. All right. So one second. So before we start, well, since you already know what functions is, we might just get into a few practice first, and then if there's anything that's not clear, we'll go through the concepts. Initially, I was gonna go through the concepts with everyone, but since you're the only one here, I think we can just get to practices first.
Okay.
You do the homework I gave you, the practices,
Which homework?
for the one-on-one lesson.
I haven't done it yet.
Okay. Yeah, I purposely excluded those practice out of this lesson because I knew you might have done it. So yeah, you can do them in your meantime, and then the practice in this lesson will be different than the ones I left you.
Okay.
Okay. So first one, this is an example, right? Yeah, before we look at the answers, this is pretty simple. It's asking you whether it's a function or not. Okay.
Mm-hmm.
You tell me like yes, no, yes, no. A, B, C, D, E, F, are they functions or not? So this is testing for a specific criteria, and that is to be a function, you must have a unique output for a input. Okay.
Wait, I think we did this in school.
Oh, you did it in school? Okay,
Is
so just
this the one-to-one function, the many-to-one function thing?
actually no. One to one,
Oh.
both one to one and many to one are functions.
Oh.
Right now, I'm asking whether it is a function or not a function.
Um, I have no clue.
Okay, here's the thing. A function, of course, it can be one to one, right? Like one to one is the special case, right?
Mm.
It can also be many to one. Okay. Technically, all the one-to-one functions are many to one, right?
What?
Many refers to one or more, right?
Oh, yeah.
And then we call these functions, right? We say that these are functions. They are functions. But there's like a bigger circle outside of it. This is called relation. Okay.
Mm-hmm.
Maybe I should move this. Oh, wait. How do I move this down? Yeah, by functions. This is called relation. And relation can be many to many or one to many, right?
Mm-hmm.
Okay. So when you have one to many, this is not a function. Okay. By definition, this cannot be a function. And a classic example is here. You see it?
Yeah.
One is being mapped to 2 and 6 simultaneously at the same time, right?
Yeah.
So this cannot be a function.
Uh,
Okay.
yeah.
So I'll say this again. To be a function, you must have a unique output for a input, for any input. Okay?
Wait, which one's the input and which one's the output? X is the input, right?
Yeah, by default, left is input, right is output.
But
Arrow going this way. That means input is 1, output is 2.
so one input can only have one output.
Yeah.
Okay.
But one output can have
multiple input.
Yes.
Okay. So
ABC, just start tell me yes, no, stuff like that. Yeah.
are A and B all yes?
Okay. A is yes. What about B? Is B yes or no?
B is no.
Why?
Because there's 5 and the first and second one and the third and fourth one both have the same input.
Yes, and different output. Okay. What if I say this? 20 and then 40.
Would be yes.
Technically it would be yes, because this notation here, this is a set notation. Okay. Technically, a set cannot have repeated values. Okay. If they're repeated values, they're treated as the same one. It's a collection of items. That means you cannot have the same thing more than once. Okay. So technically, if they're the same, then we treat them as one. But that wouldn't be in the exam. That would be very weird. So anyway, this is a no. What about C?
C is yes.
Yeah, easily yes. Okay. All right, we keep going. What about E and F?
E yes.
Mm-hmm.
And F also yes.
Okay, that's correct. Some student might think as F as the inverse of square, but if it is inverse of square, it looks like this, right?
Yeah.
But remember, square root of x, this cannot give you a negative number. So this is actually wrong, right? It's not the it is the inverse, but we're not including the bottom part. Okay. Square root actually only gives you positive number. It cannot give you negative number. Okay.
Yeah.
Okay. So it works like this. Although we can say -1 squared is +1, but square root of 1 gives you does not give you -1. Okay.
Wait, so square root of 1 does not give you -1?
Yeah. So a square root is the opposite of square, right? But not all the time. For
example, yeah, because
it
can't be negative.
-1 squared is 1. But we would think if we square root both sides, right?
Mm-hmm.
We get what? Okay. If this is true, what's going to happen? I'm going to write a very interesting proof. Okay, let's say we have negative x equals negative x, okay? Or if I say this, if a negative k equal -1 equals -1, right?
Yeah.
Now if I do something like -1 squared equals -1 squared, right?
Yeah.
And then left hand side, I take the square root again. Square root of -1 squared equals, this is +1, right?
Mm-hmm.
And then I'd be like, oh, square root and square cancel out. This is -1 equals +1. Right? Of course, this is not true. Of course, this is not true. So there has to be a flaw in the step. And the flaw is from here to here. This is not correct. Okay?
Yeah.
So square root does not always undo the square. Okay?
So is that only in this occasion?
Whenever the inside is negative, it does not undo the square. It keeps the positive.
Oh.
Yeah. It's a very specific scenario to remember.
Oh.
Did we talk about anything about a square root? Yeah, it's pretty much says every, yeah, because if we exclude a negative value, it looks like this, right? That means it's unique. There's nothing not unique about the output, right? Cool. All right. We have more exercise here. Determine whether the function or not a function for the reason why. This is pretty easy. We don't need to do this. What about the, oh, it's everything. Okay, this is pretty much the same thing. Let's just pick a few to practice, okay? Uh, is this a function?
Where?
Is
Oh.
this a function?
Yes.
Okay. Because yeah, for whatever reason it is. Yes, there's a unique output. Okay.
Yeah.
What about G?
G is yes.
Okay. What about K?
Okay. What? Is it also yes?
Okay. What about J?
Yes.
What about I?
Mm, no.
Y?
I don't know.
Okay. Good sense of intuition. This is a no. And the reason why is because we plotted. This is 3, right? This is the line here. The line is right here, right?
Yeah.
The line is right here. And that means there is a, for this single, because we're treating X as the input. And the input is 3, but 3 technically can get us anywhere, right?
Yeah.
This 3 can get us anywhere we want in the y-axis, so no. So that was a little bit abstract, but yeah. Let's do some dodgy ones. The number of movie tickets purchased and the total cost.
Wait, which one? C?
Yeah, C.
The number of movie tickets purchased and the total cost. Yes,
Why?
because each one you buy like adds it's more money.
Yep, that kind of makes sense. So you cannot get any, like, assume you can't get any free tickets. Like, to get one more ticket, you pay a different amount of money. You pay more than money, right? One more ticket, more money. So it's never the same money. So it's never the same number of tickets that you pay 2 different money, right?
Yeah.
In fact, this is actually 1-to-1 as well. Okay. All right,
Yeah.
that's cool. Okay, did you learn domain and range?
Range.
I think we did domain and range, right?
Yeah.
Okay, so let's look at some exercise with domain and range. Draw the graph of a possible function for each of the following domain and range. Okay, so it's saying given the domain and range, just give me a function that has this domain and range. Do you get the question?
I think so.
Okay, so try A. You just need one example for it.
Wait, what am I doing? Am I drawing the graph?
Well, actually, just give me the. Yeah, like you can draw a graph. You can give me you can give me the equation. I can draw you the graph. When you became really good at drawing graph, like having the equation and draw the graph is pretty much the same thing.
Wait, I don't know how to do it though.
So first of all, here domain range of x and y equal real number. There's pretty much no restriction, right?
Yeah.
You could just be like y equal x, right? Whatever in, whatever out. The graph would look like something like this.
Oh,
This is y equal x. Okay. Does that make sense?
yeah.
All right, what about here?
Mm, is mm, is y bigger than 3?
Yep, that is the range. That's not the graph, but that is the range, yes. This is a very weird notation, though.
I have no clue.
It's actually pretty easy. Think about what function.
Oh, does the wait, how do you want me to do this? Is it like that?
You can draw on here. I mean,
Oh,
you gotta need some axis, right? And 3 is right here.
oh wait. That ignore that. Is it like that?
Wait, that's only, wait, let me rub it out. So you mean this? And straight line on the left?
Yeah.
That works. That works. That's fine. That's what we call piecewise function. Okay.
Oh,
So yeah, that's what we call piecewise function. So that's fine. But that requires 2 lines. So when you write out the function, you be like this. See, this is a piecewise function. You do something.
wait, so how is it supposed to go then?
Oh, that's fine. That's one of the correct answers.
What's the other one?
The easy one will be x squared plus 3.
How is that drawn out?
This. Plus 3 is a simple upward shift. And x squared allows all the input from the real numbers. Anyway, let's look at this graph first. So when x is positive, right, this is pretty much y equal x plus 3, right? Bigger or equal to 0. And when it's smaller, you could technically do this as well, right? You could do another curve, right?
Wait,
But
wait, is it still B?
yeah, still b. Technically, you could do this, but if you want to do this, you could just say y equals 3, right?
Yeah.
X is smaller than 0, right? But we don't say y equals 3, we just say function equals 3, because the function is represented by the y-axis. Okay.
Wait, why could it be like this? Why can it be like that?
Y can or y cannot,
Why can it?
because that satisfies the domain and the range.
But I thought oh,
Right. So first of all, the domain, you allow all the numbers from the x-axis, and the range, it only spits out, it covers every number that's greater or equal to 3.
so is that the easier way?
Oh, no, in my opinion, the easier way is just x squared plus 3. Right.
Is that wait, how did you draw it again? Is that
What
just
does x squared look like?
the diagonal line, is it? I don't
No,
know.
x squared is this.
Oh,
Plus 3 is an upward shift of 3 units.
oh yes. Okay.
Okay.
Yeah.
And there's even a thing called absolute x. Do you know what this looks like?
Mm.
Absolute x means whenever x is negative,
It's positive.
It's positive. You flip it positive.
Oh yes,
Absolute comes from the idea of distance, because you never say negative distance, you just say positive. So let's say this is you, I'm running away from you this way, and distance, when I'm at you, when we are at the same location, distance is 0, right? But as I'm running away, the distance increases, right? But if I run away the other side, the distance increases as well.
Yeah.
Okay. So absolute x literally looks like this.
Oh.
You can think about it as making a negative number positive, or you can think about it as the distance between x and 0. Okay.
Yeah.
So well, I was gonna do something. Yeah, that was pretty much it. Okay, any questions before we move on?
Oh.
Okay, let's try C. Slightly harder, but shouldn't be too hard.
The domain.
You can try draw it first, okay? If I were to draw this, I'm gonna help you with the diagram. Okay, so I've drawn out pretty much the diagram for you. And now you just want to draw something, draw a line.
Wait.
Don't overcomplicate stuff. Don't overcomplicate stuff. Think about what kind of graph is gonna take that input and take that output.
Wait, is this a function?
Is what a function?
This. Like the thing.
You haven't drawn anything. Yes.
But I thought it couldn't be.
Oh wait, no, it's not a function. If you put it vertical, then yes. No, it's not. Yeah, it's not a function because one x value is good thinking. Why don't you do it vertically?
Because it can't go through the y-axis twice.
No, do this.
What?
Yeah, like this is not a function because one x value corresponds to two y value, right?
Yeah.
One input corresponds to two outputs. So no, this is not okay. But good thinking. Why don't you do this? Just treat this as a box, right? Treat it like a box. Right? So why don't you do this? Right? It's only asking you to draw the graph, right? Like what the line of the graph is doesn't matter that much. Okay.
Oh, okay.
You know what's actually easier? Why
What?
don't you do this?
Oh,
Is that easy?
yeah.
I think that's probably the easiest one.
So one function can have like multiple,
Multiple input to one output.
no, multiple like ways to draw the graph.
Oh no, like no. One function must have a unique way. But this question, look at how it's phrased. Read the question. Draw the graph of a possible function.
So what does that mean?
Your restriction is the domain and range, right? You're not given a function. You're just given the domain and range. Be like, oh, give me a function that has this domain and range.
Oh.
like, okay, there's infinite functions that has x reals to reals. For example, y equals x, y equals x plus 1, y equals x plus 2, y equals 2x, y equals 3x. You got the idea. Okay. So we're just trying to find the easiest one. But this one has to be, okay, it's note how this is smaller or equal, and smaller, okay? So at 6, 2 have to be like an empty point. At here have to be a solid point. Does that make sense?
Yeah.
Okay, so by empty point, I mean, when we define the function, we literally just say, okay, what is tell me first, what is this line?
What line?
What is this red line? The equation of this red line. I understand it's not asking you to define it, but as an exercise, we are doing it.
Y equals, wait.
What's the gradient?
Wait, no, hold on. 5 over 6.
Nice, rise over run, right? This is 5, this is 6, right?
Yeah.
I mean, my drawing is a little bit abstract, but this is the idea. I subtract by 3, y-intercept. And then you need to specify the range, right? So, okay, so if this is a function, we do something like this. We do something like this. You just say fx, which is y, equals to 5 over 6, x minus 3. And then you want to restrict the x to be within, you want to restrict the domain to be like this. And then it's automatically the range is this, okay? Because when you substitute 0 in, you're gonna get -3. And when you substitute 6 in, so here, you're gonna get 2, right? So here you don't have to even write the range out. It's all because you have plotted this line correctly according to this equation. The range is automatically this if you try to work it out, right? Does that make sense to you?
Yeah.
All right. And all right, let's see. Yeah, notice how I must have this thing on the top because it says smaller than 6 and smaller than 2. Okay.
Yeah.
Oh, right. And same goes for your previous idea. I mean, it could work, but you gotta do something like this. Okay.
Yeah.
But that has a problem because if we leave those 2 points empty, the
But
domain.
It could go up. Wait.
No, the domain is this. It's no longer greater or equal to 0. This is simply greater than 0 for the domain.
Oh, okay.
Right. So domain you're leaving to n empty. It's greater than 0 and smaller. Oh wait, sorry. Strictly
Wait,
greater than
wouldn't
0.
it be the same with the line?
No, for the line because we're doing like this. This is solid. This is empty.
Wait, what is solid? Solid means including.
Yeah. So this is that.
Oh.
So if we do this, that becomes a problem.
Oh.
And if you keep thinking, okay, what if we just make this less or equal to, right? Then this becomes a solid point, right?
Oh.
But now if you look at the range, this is actually y, -3, and then less or equal to 2. It's equaling 2, right?
Yeah.
So this is actually not fine considering how weird this sign is. Okay.
Yeah.
But like the idea was on the right track. It's just that it turns out this didn't work out in the end. And this is probably too easy. Like if you do that, we will just do something like this. Boom. Okay.
Yeah.
X bigger than 0, y bigger than 0. Just do a line like this. Cut it off here, right?
How do you know when to do like the circles?
Circle.
Like the like
empty
the
point.
yeah.
This point is simple. It's a simple notation for big strictly greater. Okay. When there's a dotted solid line, it's just
Equal.
including that point.
Oh, okay.
Yeah.
Okay.
I can do one more practice on this since you are asking. Okay. So let's say we have this line, this graph here. We have this line segment. Okay. This looks like 2 and maybe 4. And this is like maybe 1 and 4. Okay. How would you want to plot this? What is the line for this? This is a good practice for linear algebra as well.
Wait, what do you want me to do?
Find the graph. Find the graph, and then we'll
Is
find
that not the graph?
the equation of the graph.
Oh.
You can take your time.
Wait, I don't. Do you want me to do it like that?
Yeah, but this is not piecewise. This is not piecewise, so one line is fine. So y equal mx plus c. But in the end, you can replace y with fx since we're doing functions.
What?
There's a neat trick with functions, right? If you don't really get a concept, just replace y with fx and you are good. Flip down. Okay. Now work out the intercept.
Wait, how do I work out the intercept?
So if you write out everything, y equals this plus c, right?
Oh, make y. Oh, make zero x 0. Wait, hold on. No.
No, because you don't know what y is. So in this case, you want to substitute a point. Because you don't know the full equation yet. If you know the full equation, make x 0, you get c as the y-intercept, right?
So I put something in as x and y.
Substitute a point from the line. Because right now you have 3 unknowns, right?
Hmm.
But technically, x and y are a variable, so only one unknown. So you want to find something that can give you x and y. In that case, just substitute a point in there.
Oh, okay. So
Oh, sorry, 1. Yeah.
the 2 equals 2 over 3 plus c.
Yeah. So what is c? Yeah, you got it. What is it?
4 over 3.
Yes. Yeah. And then we can write it in terms of a function like this, right? But you want to give it some restrictions. So in this case, we only have to restrict on the x value, and the y value is automatically satisfied. Okay. Because when we plug the x value in, let's say we restrict on the x value. In this case, what should be our restriction? What do we write here? So like our domain, what is it?
Domain is equal to or bigger than 1 and equal to or smaller than 4.
Nice. Okay. That was the whole thing. Yeah, that's pretty much this question. And then we don't have to write the range because if you substitute this in, you're gonna get what is f of 1? And what is f of 4?
2/3 plus 4/3 is 6/3, which is 2.
Okay, what about f of 4?
Um,
There's
4.
a smarter way to work this out.
4.
Yeah, 4. Just look at the graph.
Yeah.
Because we got this from the graph, and then this is the boundary point. So it's just this point and this point is 2 and 4. Okay.
Mm-hmm.
So that's gonna give you the domain is gonna give you your range, which is between 2 and 4. Okay. So in this straight line, in this case, you just have to worry about the domain. And unless it's asking you for the range, you don't have to write it out. This defines the function pretty well.
Yeah.
All right, cool. All right, let's see if there's any more interesting questions. The piecewise function. Find its value, get the graph of that, write down domain and range. Okay, question 4 is pretty interesting. All right, let's do question 4. So do A first. What is F6 and F8? So tell me which equation are you using? Is it the first equation or the second?
Second.
Why?
Looks easier.
Okay, who said it's continuous?
I don't know.
You got what I mean?
No.
So this says stricter bigger than 6, but less than 6, right?
Mm-hmm.
So technically you should be using this one because x right now is equal 6. Less or equal to 6. So at 6, it should follow the first equation. Right? Right. Do you get what this means though? Like what this piecewise function means?
No.
So pretty much it says when x is between 0 and 6, our function looks like this. But when x is between 6 and 10, our function looks like this. Okay?
Mm-hmm.
There's two pieces. It's something like you got 0 and 6, 0 and 6 and 10, right? Before that is this. And then after that is minus x plus 10, something like this, right?
Yeah.
Okay.
Wait, so I don't get what I'm trying to find.
You're trying to find what is when you put 6 inside the function, what is the output? F of 6. So first of all, you look at the criteria. I said when f is 6, you should use the first one because it says at the back x less or equal to 6, right?
Mm-hmm.
So that's when you use the first one. And in this case, you do use the first one. So put 6 in, what do you get? You get 4, right?
Wait. Oh, yeah.
Yeah. 1/3 times 6 plus 2, right?
Yeah.
All right. And it turns out, do some quick checking. Even if you use the second one, it is 4, okay?
Yeah.
That means the function is continuous, okay? So it does not look like this, but rather it looks like this. Like at 6 is connected, okay?
Yeah.
So that's what we call continuous. All right, what about F8? Which equation do you use?
The second one,
Why?
because x is bigger than 6.
Okay, so it's defined to it's defined in the second region, right? 8.
Mhm.
I don't know how to say this in English, but yeah. So what is F8?
2.
That's it. 2. Okay,
Yeah.
cool. So, what else? Yeah, that's pretty much question A. Then question B, sketch the graph. Okay, sorry, it's saying is from 0 to 6. Okay, 0 to 6 to 10. Okay, so do 0 to 6 first.
What?
You get what the question is asking?
Find the value of f6.
No. Part B now. Part A, we're already done.
Oh, right. Sketch the graph of f. I don't really get it. Do I just
Yep, do it separately. Do it one by one. So don't look at anything else. Look at this first. How do you sketch this?
do I do from 1 to 6?
Technically, it's too you don't want to do that. That's too much work for this problem. Just sketch it like how you sketch a line, because you know it's a line, right?
Oh. How can you tell if it's a line?
It's y equal mx plus c. It's just you don't have the y equals to. Instead of you have the fx. You got this, right?
Wait, I thought that was the. Wait, so is this the equation and then the back here is what is the back here then?
It's the restriction. It's saying within this region, our equation is that.
Oh, what?
Yeah,
I thought that was like the domain or something.
that's the domain. Yeah, that's
What?
okay. That is part of the domain. It's saying within this region, our function follows that. That's what we call piecewise function. Okay. All right, listen now. I'm gonna tell you what it is. We got fx and a bunch of equation, right?
Mm-hmm.
And this is, let's say, x smaller than 0, x between 5 and 0, and then x bigger than 5, right?
Mm-hmm.
And then we have a graph. X bigger than 0. Okay, we have this graph here. Let's say this is 1. This is your graph 1, okay?
Mm-hmm.
But it stops at 0, right? And then you got your graph 2 from 0 to 5, right?
Mm-hmm.
This is your graph 2. This is your 5. This is your graph 2. And then you got your graph 3. And then this is your 3. This is your graph 3, okay? So that's piecewise function. It's pretty much 3 things put together. Does that make sense?
Wait. Wait, is that using question 4 as an example, or did you just use random numbers?
That's just random example. Because question 4 have 2 equations, we have 3 equations here, just random numbers.
Okay.
Like just 1, 2, 3. I'm not even writing out the equation. I'm just like saying equation 1, equation 2, equation 3. Right?
Okay. I think I get it a little bit. So would for question 4, would that be 0 is smaller than and equal to x?
That is the boundary. 0, okay. Between 0 and 6 is pretty much this region, right? This region here. This region, right?
Yeah.
So just plot this line first, but you're only plotting this region. Just,
Oh, but would okay.
yeah, just plot y equals. Just plot y equals a third x plus 2. Just plot this.
Well, but I don't understand how you do it if you don't have anything to do it off of.
Okay, just plot y equal third x plus 2. Just plot this. Don't think about anything else. Just plot the line.
Plus 2.
Yeah.
Wait, what was it?
Here, y equal third x plus 2.
Third x.
I can give you a hint. You already figured out a second point, which is 6 and 4, right?
So would it be here?
So you can, yeah, you can get to the second one straight away. Yeah. Draw a line. Yeah, nice. That's done. Okay. But because it's a piecewise function, you only plot from 0 to 6, not all the way. Okay.
Is that not from 0 to 6?
That is. So I'm saying, like, instead of going all the way, you do what you just did. Okay.
Oh, okay.
And let me just tidy things up a little bit. Good. Okay. All right. Yeah, that's the whole point of piecewise function. It limits your line between these 2 points. And then when it's from 6 to 10, it has something else. Okay. How do you plot negative x plus 10?
X plus 10. Mm, the y-intercept is 10.
But the thing here is that you can't plot from the y-intercept because it's in this region, right?
Oh.
You get what I'm saying?
So there's no 10.
There is, like, technically you can draw something here and draw it down like that, right? You just want to erase this part.
Oh, okay.
Okay.
So how
But
do I just I don't know how to do it.
yeah, sorry.
So I don't know how to do it then.
Okay. So since it's a straight line, we don't necessarily need the y-intercept. We just need 2 points and makes a straight line, right?
Yeah.
We already know 8 and 2. Yeah,
Mm.
right, 8 and 2.
Yeah.
And remember, we kind of verified it at 6 and 4, right? Although this is greater than 6, but if we try to put 6 in, this is about, it gets to about where we have right now. It gets to about 4 as well, right?
Mm-hmm.
So because we're just looking at this line itself, doesn't matter about it. This doesn't matter. We're just trying to get the shape done and then cut it, okay?
Mm-hmm.
So we can plug 6 in there and we get 4. So this is a point, right?
Mm-hmm.
And 8 and 2 is also a point, right? And obviously 10 and 0 is a point, right?
Yeah.
Yo, Michael.
Yo, sup?
Yeah, good. I'm good.
This is bad news. There's a mosquito on my face. Okay, anyway. So this is how you plot this function, okay?
Yeah.
Cool. That was a little bit hard, but Ryan, did you ever do piecewise function?
Do what?
Yep, never mind. You didn't even do function. Okay.
Yo, I'm not year 12 yet, bro.
It's okay. Hannah, do you have any more questions about this?
No, I don't think so.
Okay. In the meantime, I will introduce Ryan to, like, the basic piecewise function concept. Okay. Hannah, if you want to take a break, you can take a break. Otherwise, I think I'll spend about 5 minutes talking to Ryan about the piecewise function. I mean, it's pretty much time for break as well. But if you want to stay and listen, feel free.
Okay.
Okay. So Ryan, continuing what we did from today morning, right? Function input output, right?
Yeah.
So right now we are talking about something new. It's called piecewise function. Okay. So let's say we have this graph. Yeah, Hannah, you can probably hop in as well because this is like summary for what we just did.
Okay.
And instead of having one straight line, we'd be like, okay, let's start with a straight line. But when it gets to a certain point, we want to use another way to represent this graph. We want the graph to go down, right? This is very useful in real world modeling. For example, tax brackets, right? You pay a certain number of tax. Let's say you pay 10% tax when your salary is below 100,000, right?
Mm-hmm.
And then suddenly, when you get up to 100,000, you pay 20% tax. This is a classic piecewise function, right? If I ask you what is f of 5,000, right? What is this like?
Wait, what do you mean?
So right now, if you make $5,000, how much tax do you pay?
10%,
Yeah,
right?
so f of 5,000 10%. So I'm defining this line to be the function. Okay.
Yeah.
What about f of 12,000?
Wouldn't you still have? Oh, you'd have to pay 20%.
Yeah. I'm gonna make this graph quite accurate. So we got a solid line and we got a circle line. Circle. Okay. What about f of exactly 10,000?
10%?
No, 20. Because look at it here, the circle means that this point does not include 10,000. Okay. It means
Okay.
anything below 10,000.
Yeah.
Anything below 10,000.
Okay.
And the other criteria is like above and include 10,000.
Mm-hmm.
So this is what this solid dot and the empty dot means. Okay.
Okay.
Cool. All right. So now let's write the function in proper terms. First of all, you start with fx, right?
Yeah.
But in piecewise function, you do this kind of stuff. Okay. First of all, it equals 10%.
Mm-hmm.
If we write a comma here, if x is smaller than that, but equals 20% if x is bigger than that. Okay.
Mm-hmm.
So that's a very basic piecewise function.
Okay.
Okay. In terms of a graph, you could say something like this. You could like roughly informally represent this like this: y equals 10% for x smaller than whatever, and then y equals 20% for x bigger than whatever. Hannah, does this make sense?
Yeah.
Okay. And this could get really complicated if we don't use a simple straight line. Okay. Let's say we have this function. I'm just gonna do an example here. Let's say below 0 is a what? Is a straight line going down to 0. Okay. Let's say this is y equals negative 2x. Okay. And then it go up, it becomes a quadratics with something like this. Okay.
Yeah.
And okay, let's do a quadratics. No, let's do an easy one. The quadratics like this. Okay. Where this is probably like 1, 1. Okay. Or 1, 2. Okay.
Mm-hmm.
So revising from the content with the last week, this is the vertex form. It's given the vertex, right?
Mm-hmm.
Can be y equals a and then x minus. Okay, can anyone give me the equation for this?
The vertex.
Yeah, the vertex form. Actually, if you know it, type in the chat. I'll see if both of you know it or yeah. Vertex is 1, 2. So what is the equation? already make a variable. So yeah. If you know it, type in the chat to me.
Mm,
Oh, actually, A is A is deterministic. A is a value because we already got 0, 0 there as well.
oh my. Yo, I'm gonna just guess.
No, you didn't use 1 or 2. You didn't use 1 or 2 in the equation.
Oh,
Just check last week's notes. Hannah, do you notice?
Yeah, but how do I do square? How do I, oh wait.
You pretty much just plugging it in the formula.
No, I know. I don't know how to type out square.
So just write a 2. I'll get what you mean. Well, I'll get what you mean. Nice. I think you got everything correctly. Okay. Ryan, look at this. The x coordinate, you're kind of shifting right by 1, shifting up by 2, right?
mm-hmm.
That's how you remember the vertex form. Shifting right by 1 is you directly subtract 1 to x, right?
Yeah.
Because you start with this. Wait. Oh crap. Because you start with this, right?
Yeah.
And you move it right by 1. So to subtract 1 directly to x. And you move up by 2 plus 2. But remember, there's a vertical stretch. Although this form fixes you the vertex, right? The vertical stretch is A in the front here, okay?
Okay.
And Hannah, that's very good answer. Like the vertical stretch can be determined by looking at this third point, which is 0, 0. If we put 0, 0 in there, we got 0 equals A times 0 minus 1, which is minus 1 squared plus 2, right? Which pretty much get 0 equals A plus 2, right?
Mm.
Oh, Hannah, it's actually negative 2. Yeah, we get negative because it's curving down.
Oh yeah.
Negative 2. Okay. So you can think about it stretching it twice. It's stretching it twice as high. Okay. Because normally when we have a quadratics, when we get a 1, this is 1. But here, this is like 1 unit away from the vertex, right? But this is 2. So you are stretching it twice. You can think about it like that. Okay. But the vertical stretch is negative 2 here. Okay. So that's the equation of the quadratics I randomly put in. Does that make sense?
Okay. Wait, what does the A represent?
Vertical stretch.
Okay.
Shift, stretch.
Yeah.
And yeah, horizontal and vertical shift requires 2 numbers, but vertical stretch or horizontal stretch, they are the same thing. Because horizontal stretch is pretty much vertical compress. Okay.
Okay.
So they can be represented in this one single number.
Yeah.
Cool.
Oh, cool. And what does the +2 represent?
Vertical stretch. Sorry, vertical shift up by 2 units.
Okay. Yeah.
So the general form is this: y equals a bracket x minus h or k, and then plus h, and then the vertex would be k and h. Okay. All right. Anyway, the key here is not quadratics, but to think about how to represent this piecewise function, right? And it's not too hard. It's pretty much, again, you split it into x bigger than 0 and x smaller than 0, or x smaller than 0, x bigger than 0. Okay. And you have to make sure that one of them included 0. So let's say x smaller or equal to 0. Okay. And the equation is negative 2x and negative 2x minus 1 squared plus 2. Okay?
Mm.
So I'm just putting the two different equations in. And there's nothing too hard about like putting this all together. Okay? When you have the equation piecewise function, you just put it together. Does that make sense to everyone?
Yeah.
Cool. All right. Let's go back to what we were doing before. All right. I think we do question 5 and then we'll take a break. Okay. Consider the graph of piecewise function. Find the equation of the function, including an interval of the domain that applies to each part. Okay, so it's pretty much giving you this and then ask you to find the equation. Okay, so let me think. Okay, once you guys get the equation, send it in the chat. Okay, you can send it one by one, and then I can help you to check it. Okay. There's going to be 3 equations of 3 lines, and then lastly, you put them together with their intervals. Okay. If there's any questions, ask me anytime.
Michael,
Yo.
where do I even start, bro? I haven't done anything like this before.
Okay, if you extend this line, how do you find the equation of this line?
Rise over run for the gradient.
Yeah, something like that. Just find the equation of the line.
Yeah.
And
Oh, wait.
no,
No.
it's just a straight line. Find the equation of the straight line. Right?
Okay.
This one is pretty obvious.
So then I have to find it for both of them, like the negative
There's
3.
3 of them.
Oh, all 3, I mean. Yeah, the 3 lines. Okay.
You can send me the answers one by one.
Yeah.
Yep, Hannah, that's correct. Move on to the second line.
Wait, Michael, once you find the gradient for like all 3 lines, what do you do after that?
Why would you find a gradient for all 3? Find one line like all together and then move on to the next one. Find the
Well,
equation of every line, gradient and y-intercept,
oh,
and then just type the line to me.
yeah.
Hannah, that's correct for all 3 of them. Okay, now try putting it together with like the range. Oh, sorry, domain.
What?
So you're trying to write the function, the piecewise function in this form.
What? So will it be 3?
Pardon? There will be 3 equations, yes, and 3 intervals. I think it's quite intuitive. You just say between where and where it is this, between where and where is this, between whatever is this. right?
How do I do the?
You
Oh.
kind of copy this format, copy this form.
I think I know.
Okay. Okay, Ryan, let's see. Yeah, that's correct. You can simplify it. You can simplify the second one as well.
Oh yeah.
You're missing an X in the second one.
Oh my bad.
Ryan, not Ryan, Hannah, that is correct. For the first line. Yep. That is correct for the second one as well.
Michael, for
Yeah.
the third line, the one like on 7,
Flat.
the flat one, how do you find the y-intercept for that? Do you just extend it?
Yeah.
Okay.
It's a straight line going through 7. So what do you think the line is? We did this last time.
Yeah.
Linear equation.
Wait, so would it be like that?
Yeah, you wouldn't want to say 0x equals 7. If it's horizontal, just say y equals 7. If it's vertical, just say x equals 5.
Okay.
Right.
Okay.
Hannah, okay, a few things, Hannah. First of all, it tells you it is smaller than 6. So you say you should be
Oh.
saying between 2 and 6 instead. Okay. Another thing is you always use less or equal to. You always use strictly less.
I don't know how to do that.
Ah, okay, I see. Okay, that's another thing. The third thing is even if you want to say this is bigger than 2 and all the way to infinity, right? You don't say this. You don't say this. You just leave it out empty. Okay. Or you don't say smaller than real, because this is a set. This is not a number. So you don't want to do smaller than real. This doesn't make sense. Okay. So if you want to say it goes all the way to infinity, just leave it out like that. Okay. Make sense?
Yeah.
Okay. So Ryan, you pretty much got the equation, except you need to kind of simplify it a little bit, right?
Yeah.
All right. In
And
the meantime, I'm gonna do the answer.
how do I combine them to create the piecewise function?
Yep. So this is the format you should be writing it in. There's no, it's pretty intuitive. It's pretty much saying fx equals to, okay, we got 3 cases when x is between -1 and -3, right? In this case, you got to make sure that you have less or equal to for -3, okay?
How do I
Because
get the
x
symbol?
equal to, sorry?
How do I get like the symbol like with the equal to or something?
Oh, it's okay. You don't have to stress about it. If you type me this, I'll get it. Okay, and then you got between -1 and 2. Here you got to decide whether to put less or equal to sign here or here. Do you get what I mean? You have to pick one. It doesn't really matter, but you have to pick one here. Pick one, okay? Does that make sense, Hannah?
Yeah.
So you have to include the point -1. You can't have strictly less and strictly less for both of them. That means -1 is not included, right? So you have to pick one of them to include -1. Same goes for here. So I just picked this one, okay? And make sure it's strictly less or equal to 6, because it wanted to be less or equal to 6, okay? It already tells you the domain is from 3 to 6 inclusive. So you want to include 3 and include 6. Make sense? Does that make sense, guys? Does the intervals make sense?
Yeah.
Ryan?
Could you explain it again? I don't really get it.
Okay, all good. So right now we breaking out the intervals. One is from -3 to 1, and another
Yeah.
one is from -1 to 2,
Yeah.
and then last one is from 2 to 6.
Yeah.
I'm just writing it out like this.
Okay.
I was having it here, right?
Yeah.
And I was just stressing about how we have to include -1. We can't have both of them being like this. We can't have both of them like this.
Okay.
So we have to include -1 at one equation. The value is the same, so it doesn't matter.
Okay.
Sometimes the value is different, sometimes it's this. Right? In that case, you want to include -1 here.
Yeah.
All right, and then with each interval, what is the equation? The first one, as you said, is y equal -x, but we ignore the y, just -x, okay? Second one is, what is that? 2x plus 3. And the last one is 7. It's a constant, okay? So now once you got this whole thing, you can try to read it through, be like, okay, let's say I got this function. I don't even have the graph, I just got this function, right? What is my function? Let's say, what's my function when f is 0, right? You'd be like, okay, f is 0 goes here, right? 0. F goes 0 belongs between here, right? And in that case, you'd be like, okay, what am I going to get here? F of 0 equals 3, okay? From this, which is correct, okay? Make sense? Or question?
Kind of.
Any questions, guys?
No.
Okay. That was a lot of stuff stressed about that. Okay, we're gonna do a few other function application questions after. We're gonna have a break, 5-minute break for now. And then we'll come back, okay? Cool. In the meantime, ask me if there's any questions, all right? All right, guys. Let's continue. After this, we got okay. That's it. Oh, we got pretty good progress today. So we have this. This is a application question, and then below we have some technical ones. What do you guys want to do? Technical or application?
I don't really mind.
Anna?
I don't mind either.
Okay. Then let's just do a little bit of both. Okay. Let's look at the first one. Plumber charges $40 for a call and $21 an hour. Write a function that represents the situation and define the variable use. Okay, so let's do A first.
Wait, do we have to put like fx in the front?
Yeah, sure. The variable doesn't really matter, but yeah, sure, it'll be a function, so. Okay, Ryan, that's correct. Hannah? Ryan, you can move on to B and C.
Wait, Michael, for reasonable domain and range, does that mean like,
Up to you.
oh, so like we could put for like 24 hours or something, right?
Yeah.
For the domain.
Up to you. Yeah, when I saw that question, I was like, huh, what is the domain?
Okay.
I'll say probably 8 hour at max.
8 hours. Okay, I'll just
Hannah, that's correct. Okay. So both of you have got the answer for fx equals standard 40 plus 21x. Okay. Okay, here I'm just gonna interrupt you guys. A more maybe interesting notation, because you know it's gonna be the price, right? How much price or money or cost. So you can use P instead. And the variable, since it's hours, is time. So why not use T? Okay, so we can do something like this as well. Okay.
okay.
No difference, but yeah.
Michael, for
Yo.
do you just do like 61 and would you write between like example between like two numbers and that's okay.
You don't have to stress on the notation, right? Is that what you're talking about?
Yeah, okay.
I think even in IB, like in the final exam, even if you don't use the set notation, it doesn't matter that much. You don't want to say 8 hours. You want to say between 0 and 8.
Oh, okay.
All right, Hannah, let's agree. Let's just agree on what hours are you using, Hannah?
I don't know.
Let's just use 0 and 8, all right?
Yeah.
It have to be 1 and 8, I think. Yeah, 1 and 8. Right. If it's like 30 minutes, we count it as 1 hour.
Wait, Michael, but could you do 0 hours? Because like wouldn't they have to have 1 hour for work? Or does the service call could you just do that as
Like technically you're not gonna be working 0 hours, right?
yeah.
You
So
could be working 10 minutes, that's 1/6 hours. So I mean like 0 is fine. Like 0 or 1, I wouldn't stress.
okay.
But if you say 0, then your range will start from 40.
Yeah. Okay. So that'll be
So Hannah, let's just use this as a domain. And what is your range given that? Do you know?
Mm,
If there's any confusion, ask me anytime.
I don't know.
Do you remember what domain and range is?
Yeah,
So tell me what domain and range are.
the main is like the um how much or how little x can be. Wait.
Not really. Technically, it's the available or not allowed input, the defined input into the function.
Right.
So we define the input to be between 0 and 8 because realistically, you're not going to be working more than 8 hours in one call, right? And you're definitely not working negative hours as well. So with each call, you're probably working between 0 and 8 hours, right? Cool. Then what is the range? Tell me what is the range?
It's the same thing, but for y.
Actually, it's not the same thing. It's it's the possible output. Okay, similar but not exactly the same. It's the possible output given the domain. So you could say range depends on domain. Okay, does that make sense?
Wait, Michael, could you check my answer? Could I move on to C?
That was correct. That was correct.
Okay.
Hannah,
Oh.
does that make sense?
But I don't know how to figure it out.
Yeah. Okay. As I said, it's the range depends on domain. So it's the possible output given the domain, right? Okay, just tell me how much do we get paid if we work 0 hours?
40.
40. Okay, so the minimum money we get paid is 40, right?
Mm-hmm.
Okay, let's say we work 8 hours. How much money do we get paid?
208.
Yep, 208. So that's our range. We get paid anywhere between this.
Yeah.
Assuming we can work fractional hours, right?
What?
Yeah, I'm saying, okay. Let's say if we only work integer hours, then this wouldn't be continuous. Continuous means we can have 0 0.5, 0 0.6, right?
Yeah.
But if we only allow integer hours, then our domain would actually be 0, 1, 2, 3, 4, 5, 6, 7, 8. Like it's a bunch of integers. Okay.
Yeah.
But I reckon this is good enough. Okay. What about C? Ryan, okay, both of you are correct. This is 124. Are you guys using calculator?
No.
Yeah.
Oh, it's pretty quick math then.
No, I'm using calculator.
Okay, that was pretty much it. All right, let's skip all of this. Let's do some fun ones. So this is the part where we do the thinking rather than the reading. All right, given the functions f, g, and h, find f of g. All right, I'm gonna see if I can do something like this. Like, all right, next time I'm gonna leave myself some working space when I do the class, when I do this. Let's see if I can do this. Wait. Oh, nice. Great. All right, let's do you guys see this?
Yeah.
All right, let's do one first. Just do 1, 2, 3, 4 all the way.
Which one?
Wait,
One.
starting from this?
Yeah.
Oh.
Ryan, do you get this? Ryan, give it a try. Give it a try.
Which one? I. Like,
one. Yeah, I call it one. Yeah.
Wallahi, bro. What?
Give it a try. All right. First of all, what is GX? Follow my
G-
thought process, Ryan. What is GX?
GX. They're just variables, are they not? Or like,
Hannah, you know how to do this?
Yeah.
Okay, yeah, then I'll just talk to Ryan about this. What is GX? Read the given functions.
where's the given functions
But
thing?
GX is a function itself, right?
Oh yeah, okay.
Okay, and it does something to x. It's 4x minus 2, right?
Oh yeah, okay.
So what this is saying is that we are putting the output of GX inside f, okay? So altogether, this means we're putting something inside G and then inside F, and then altogether, it does something, right?
Okay.
So what does it do altogether?
All together.
Yeah.
But GX instead of F. So like the 4x minus 2 and the like negative x squared plus 5x.
Nice. Yes, exactly.
Okay.
You want to simplify it in this case. You can't just put it in and then leave it like that.
Yeah.
At least
Wait.
I understand it.
Oh. What do you get 9x with the 4x and the 5x? Would you like plus them together to simplify?
9x.
Well, there's like 4x and 5x. Could you not
Okay.
add them
Give me the unsimplified expression first.
negative x squared plus 5x and then like open brackets 4x minus 2?
No.
What?
Okay. I'll wait for Hannah
That's
to do.
right.
Hopefully it's right. We'll check. I can't be bothered like checking right now, so we'll check. Okay. All right. So first of all, there's two ways of doing this. One way is to treat the gx as an object and put it inside x straight away. So you got negative gx squared, right, plus 5gx, right?
Oh, okay.
Alternatively, you can have f of 4x minus 2. Treat it like this, okay? But anyway, altogether, it's going to be something like this. It's going to be negative 4x minus 2 squared plus 5 4x minus 2, right?
Okay. Yeah.
Now, and then I ask for expansion. So first of all, you definitely expand the square and expand this, right?
Yeah.
16x squared minus plus 4, right? Minus 2 times 2 times 4, which is 16x. Yes?
Mm-hmm.
Plus 20x minus 10, okay? Does that make sense?
Yeah. You just okay.
All right, and then make sure this negative sign like goes into every term. Hannah, did you do that?
No.
Okay, then your answer might be wrong at this step. Because this negative sign comes after all of this, after the square. Okay, you can't do all of them at the same time. So negative 16x squared minus 4. So minus 4 minus 10, that's minus 14 straight away, right?
Mm-hmm.
You're plus 16 plus 20 plus 36x. That's it.
Okay.
The simplifying is pretty much. Oh, Hannah, how did you get x cubed?
No, I did it wrong.
Oh, okay. All right. No, it's okay. I mean, we can use this one as an example and then try the next one, which is f of x. Try that. When you get the answer, send it to me. Okay.
Michael,
Yo,
second one with the f and fx one. For like with you having the minus 16x at the end, would you
oh wait, sorry, say that again.
ah for the second question,
Yeah,
and you know how you have like negative 16x because you multiplied 4 by 2 by 2
yeah.
for that? This, would you just multiply 1 by 25 and 2? Since like,
This is slightly more complicated. I can write out the equation if you like.
oh yeah, could you please?
So you can like treat the x as itself, right?
Yeah.
You can write a bracket here and then copy whatever is in there.
Mm-hmm.
And then simplify this,
Yeah.
right? So technically you can do that. So are there any questions? Oh, sorry, I forgot to square it.
Yeah, wouldn't you have okay, that's what I was.
Nice. if you guys need any help, just let me know, okay? Oh, it's been a long day. It's so cloudy today. All right, I'll give you guys 1 or 2 more minutes. Okay, Ryan got it. Not 100% sure if it's correct, but we'll see later. Okay. Hannah, do you want some more time?
Wait, mine. I don't know if this is. I don't think I did it right.
Okay, it's okay. So, do you understand the first line?
Yeah.
Okay, the first line is the same as you.
Mm-hmm.
All right, and then it's pretty much not function. Then it's just algebra manipulation, simplification, and everything. Okay, it's just purely algebra after that. Only the first step is function. Okay.
Oh.
As I said before, maybe to you, I said this to Ryan this morning. Function is a concept rather than something you got to calculate. Okay, it's an idea you got to understand. But after that is the calculation lies within the algebra, right? The function is just this idea. Okay. So that's why after this is all algebra, right? All right, so you do this expansion first, okay? You do this expansion first, right? Yes?
Yeah.
All right, so that gives you, okay, you got negative x squared squared. That is x power 4, positive, okay? Negative sign gets canceled out. 5x squared. 25x squared, right?
Mm-hmm.
So a squared, oh wait, a squared, b squared, 2ab, yes? The 2ab goes like this, plus negative x squared, and then 5x, okay? Sometimes we do minus 2ab if we see a minus sign, but it's pretty much the same thing. It's just this minus sign in the front, okay? Does this make sense to all of you?
Mm-hmm.
All right, it's just applying formula. Ryan, is this what you have?
I have 50. I actually don't have that. I have negative x to the power 4 plus 50x minus 5x to the power of 2.
Is that like your final answer? Because I haven't finished writing yet.
Oh, my bad. Yeah, that was my final
And then
answer.
expand this as well, negative 5x squared plus 25, right? That was easy, okay? Hannah, are you correct up to now so far?
Mm, wait.
If you guys see anything weird, please let me know. Like, it's very easy for me to make a mistake in these kind of questions as well, right? Because there's a lot of calculation going on. But yeah. If you guys see anything weird, let me know. It's possible that I make a mistake. I'm waiting for you, Hannah.
I got to this bit. Wait.
Yeah.
No, I got right. I got to this bit, but I didn't get the bit on top.
So then it's probably you did some,
Like I just skipped that bit.
yeah, maybe you just skip this, right?
Yeah.
You just have minus 10x cubed, right?
I got, yeah.
Yeah, I mean, you kind of have to have an extra line here because this minus sign, you kind of have to do the minus sign to the expansion again. Does that make sense?
Yeah.
No way you got from here to here straight away.
Well, I did something, but it's not that.
And you got this correctly on the second step.
No, I have something, but it's not what
Okay, then that's fine. Yeah, you can send me your working if you're unsure, but if you're sure, then it's okay. You can send me your working and I can check through it. All right. So in that case, we have pretty much got everything. And the answer is, first of all, the highest power, and then the second highest power, which x3. You always want to organize this like that. You want to organize it in terms of the power. Okay. That should be the answer, right? And is that what you got?
No, I got a different answer.
Okay. You specifically got these two wrong. You got this sign wrong here. You got minus 10, and then you got minus 5x squared. That is weird. How did you get minus 5?
Wait, I got minus 5x squared as well.
Okay, then maybe I am choking. Okay. So what did you get differently from on this line here, Hannah?
I got um, I got 25x
Plus 25x.
instead of 25x squared. Like I didn't get an x squared for this
This?
bit. Like I didn't get an x squared for that bit.
For this bit?
Yeah.
Okay, then I'm correct if that's the case. Because a squared, b squared, right? A squared is x4. This thing squared is 25x squared. You square both terms. This is 25x squared. Okay.
Oh, right.
And then
Oh, wait, I see where I made my calculation. Yeah.
okay.
Okay. Yeah.
And the last one here is supposed to be negative 10x cubed, right? This is negative 10x cubed, but you got a negative sign in front, so this becomes positive 10x cubed.
Yeah. Okay.
And that's why these positive terms becomes negative terms. So that's how this, I'm gonna circle this with green. That's how this turn into this. Okay?
Got it.
And then minus 5x squared, 25x, minus 5x squared, 25x. I think I should be correct here.
Yeah, I did everything, I think, except for the like 2 open bracket minus x squared. And like, because instead I got 50x there.
So you got 15 there.
50, but like my one was wrong because I didn't do it
How did you
properly.
get 50?
No, I did it wrong.
Okay. So since we kind of we were kind of stressed about this kind of stuff, let's just do a little bit of summary before we move on, or before we finish today. Not summary, like revision. If you have a plus b squared, what is the formula for this, guys?
A squared plus b squared plus ab.
2ab.
Oh, 2ab, yeah.
Right, Hannah? What about a minus b squared? Hannah, you do this one.
A minus b squared.
Yeah.
A squared minus b squared.
No. There's a cheeky way to think about it. You can think about it like this. A plus.
Oh,
minus
plus b.
You can think about it like this. So with this, you can use the first formula.
What?
So if I make minus b, plus minus b instead, right?
Mm-hmm.
You could treat this b like a minus b squared and treat this b like a minus b, right?
Mm-hmm.
So minus b, so you can apply the first formula straight away, yes?
Yeah.
So minus b squared is still b squared, but the minus b will make a minus sign here.
You're right.
Damn.
But I can do this, watch this, wait. We can do a squared plus, right? Just substitute the first formula. But instead of having b, we have minus b, right? And then this is what we get. Does that make sense?
Mm-hmm.
So these two are like the, yeah, one of the most important, two of the most important formulas in algebra. And then you still have this one. A plus b, a minus b, right? Also try to derive it sometimes. Just this, right?
Mm-hmm.
This is what, just say it out.
You want me to say the whole thing out?
Yeah.
A squared.
I can write it. Yeah, I can write it faster.
A squared minus AB
Okay.
plus AB minus B squared.
Okay. So it actually simplifies to a squared minus b squared. This is the third very important formula here. Okay. And a lot of the time it's going from this way to this way. Okay. That's why this is important. Okay.
Mhm.
All right. Let's see if I can tidy this up a little bit. Oh, nice. This is very tidy. Great. That's gonna look great in the class note. All right. Any questions before we finish today?
No.
Do you guys want to copy anything down before I remove everything? It's gonna be in the notes if you need it later.
I think it's fine.
Okay. Any questions before we finish? Okay, next week is gonna be logarithms. Yeah, I think, wait, let's check what's gonna happen next week. Next week is gonna be, I think, rational functions. So we're gonna talk about a specific type of function that looks really interesting. It's gonna look like this. Watch this. It's gonna be looking at, we're gonna be talking about this type of functions, okay?
Yeah.
Yeah, that's it for the whole week. I mean, if there's extra time, we can go back, do some more function practice. I mean, the point of this class is to practice your stuff, right? It'll be like list teaching, more question practice, okay?
Mm-hmm.
All right,
Yeah.
so that's it for this week, and I'll see you guys next week.
Okay. Bye-bye.
Bye.
Yeah. Have a good night.
You too.